Hi, everybody. Welcome to the 16th episode of IoT Happy Hour. And I'm delighted to have our team back, including our master wizard, although not up on much American TV pop culture, as we've just discovered. But he'll be, Chris Crocker-White will be showing off his Steampunk Geiger Counter radiation detector. And we were talking this week, there's a lot of puns with radioactive material. We will not be discussing how to acquire radioactive material.
I'm out. That's the only reason why I shut up.
Back to the Future. But we will
be.
It's just the Libyans. I don't know if that's true anymore. It's probably many more. But if you've come across this project, and it's very likely you have this week because Chris's post has been wildly popular and being picked up on Hacker News and many other places. But this project is interesting not only from the Raspberry Pi and balena functionality under the covers, but really the stunning work Chris did in building the case, the presentation, and steampunking this particular piece of technology. So as you're getting to join, we'll go around the room and make some introductions. I'm John Tonello, Technical Marketing Lead here at balena, and I'll be your host, filling in for David, who is in the wings, but taking a much-deserved break. So with that, we can go around the room. Chris said his hello, so Andrew, you want to?
Yeah. Hey, what's up, everyone? Andrew Nem, lead content strategist. It's been a while. Glad to be back. I don't have Alan's button, so I can't segue to him with the buzz. But yeah. Hey, Alan.
Hello. There we go.
Yeah.
I'm Alan Boris.
Dopamine.
I'm best known for the buzzer during the happy hour, and I'm also a hardware hacker here at balena, based outside of Philadelphia.
Trivia. Alan's never seen a cow in real life. We learned that this week.
Is that true?
I didn't say I've never seen a cow. I just said there aren't very many cows, if any, nearby.
That's not what I heard. That's not what Phil Wilson heard.
I've never seen a cow bridge, but
it's not called a cow bridge. Wait, what is it called? It's called
a cattle grid.
Cattle grid. Yeah,
it's
not a design CSS grid, but like a grid in which you use to prevent cows from going to places where you don't want them to go.
Right. So instead of putting up fences, there are these little roller-looking things in the ground, and they can't put their little hooves on them.
RG asks, "Where is David T?" That's a great question. Where is David?
David is in the wings and taking a much-deserved break.
That's true.
He can see all your comments, though. Rest
yes, he is. Yes, he is present, if not visibly.
Yeah, we gotta give him a break every once in a while. The guy works hard. David works really hard to produce an episode every week. We're giving him a pseudo vacation.
The big secret is he is the max headroom of the balena team. So he's a mix of AI and human flesh.
He's not here to control what we're doing now, so it could just descend into chaos at any opportunity.
I can see it busting up, though. I don't know if y'all have used StreamYard before, for the folks watching, but you can see people backstage. He's face palming.
And no one understands max headroom. I guess I'm dating myself. But anyway, with that, we'll transition to Mark. You're still there and visible.
Yeah, sorry, I had some Wi-Fi problems. So I'm Mark, developer advocate at balena. Based in Europe. I'm looking forward to help any developer to connect things with balena.
Mark, you just did a talk, right? Recently?
Sorry, second.
Didn't you do a talk recently?
Yeah, last week actually.
How was it?
Yeah, at the
What did you
IoT
talk
Zurich
about?
and TTN, the Things Network community in Madrid, actually
Nice.
presenting something that will, LoRa gateway managed with balena. Really cool stuff that we will talk soon, right?
Yeah, that'll be a coming topic. And for those of you who are following along, these aren't just pretty faces. They do some pretty cool projects. Check out the Balena blog at balena.io/blog to see some of the latest. And of course, in the Balena repos, Balena Labs particularly, you see the work being produced by our hardware hackers. A lot of cool things.
Ooh, can I shamelessly plug, since you brought up the blog?
Yes, I was transitioning, but you can steal my segue. Go ahead.
Pretty exciting week. We just dropped our partnership with Coral AI. Check out that post if you haven't. There's a project there if you want to get your hands dirty with local AI at the edge. Also, we have our it is. It's an amazing machine. That's how that feels. I always wonder what it felt like on the other end, and now I know.
Thanks, Lance.
Yeah. Sorry, I lost train of thought. I'm like, should I change my name to Lance now? Just see if everybody gets that Fast and Furious reference. We'll do that later. Also, huge props to SC Robotics. We've got a community member, Zabi, who wrote a prototyping guide on how they use Balena OS to prototype their GPS tracker. So check that out as well. And if any of you out there, all 10 of you watching right now, and perhaps even more for the folks who watch this later on, want to contribute your project, write about your experience with Balena, we're always down to check out community contributed posts. So hit us up.
Thank you, Andrew. And speaking of cool projects, anybody working on something particularly interesting they want to share that's still in pieces and still in bits of code?
Yeah, actually on my site, I found this Kickstarter from the Things Network Arduinos that I will connect to this LoRa gateway that I was mentioning before. So looking forward to get on the weekend to hack some Arduino code and connect it to a LoRa gateway.
See, we're so into it, we spend our free time. And segueing to, we now know what's on your desk, Mark, but what's on everyone else's desk? Any cool new stuff? Doesn't necessarily have to be tech, but could be, a chicken.
Oh, we've got the intro. What's on your desk?
I like it.
I like the way everyone went silent.
That was pre-recorded. I know it might have seemed live, but that was professionally produced and recorded.
Well, we promise we'll iteratively improve on that transition.
I mean, I don't see anything to improve, if I'm honest.
No, I like the jingle too.
Okay.
It's very memorable. What's on your desk?
It's right up there with the Howdy Doody show.
We need Matthew to play us the song. The What's on Your Desk jingle. If he's listening.
So what is on your desk?
I can go. Oh wait,
I
you
cleared
go.
my desk. I'll go.
You go.
The guy in the snakeskin pants can wait.
Yeah, seriously, that's my name. There we go.
I cleared off my desk for today's presentation, but so I don't have anything. That's a bit of a letdown, isn't it? I have some cool spanners, or wrenches, as you might call them in the US. Here you go.
Wrench?
Wow.
Spanner?
Are you gonna use this in a bit?
Yeah, I've got some tools just in case we want to take things apart. There we go.
It's not exactly tech, but it's been sitting here on my desk since I put it together, and I'm making noise, and hopefully it won't shatter. But I recently put this together.
Wow.
Is that like
connected?
It's a Lego
Legos.
destroyer
Battleship.
with moving items.
Ooh,
The gun just fell off.
did the gun shoot?
No, but there is a boom that does work.
Oh man.
Needs
My
some
father-in-law got
turbos.
the Pirates of the Caribbean one and has like working cannons. Shout out to Randy Eichhorn. I see you if you're watching. That reminds me of that ship.
maybe 4
Important
hours.
question, John.
4 hours
For you.
together.
Does it
Does it
run
have
on
a
balena?
Raspberry Pi?
Yeah.
Not yet, but it has wheels, and I was thinking of there's got to be some way I can motorize the thing to at least back up, go backwards and forwards on my desk,
That'd be cool.
and some simulated water
And buzz, right? It has
in
to
the background.
buzz.
It has to
At
buzz.
least-
It does have areas for lights because there's windows in each one of the various mountings that are hollow. I could totally light the thing up.
You definitely need some LEDs, or maybe you could put an LED alerter inside.
Yeah.
Exactly.
Exactly. It could be the LED alerter
That's a good idea.
when my ship lights up. Anybody else got something interesting?
Yeah, I have a pH tester, pen style.
Cool.
It's pretty cool. I want this to help me monitor the pH of the water in my hydroponic Kratky system. Yeah, this is an amazing machine. You're right. Gosh, that feels really good. I'm glad that we implemented that in. I am still working on balena plant. I think we're really close to like a basic version, which is like how to. I think you've all seen it, the long live stream video on our YouTube channel, where it's helping you water a small plant. I want to hit that milestone, and then next try and integrate it with the hydroponic stuff that I have going on in my garage. So fun and delicious.
That will be a upcoming IoT happy hour topic, right, Andrew?
Yeah, how to pickle mustard greens that you grow in your garage. Yes.
Sure. An IoT happy hour from your garage, Andrew.
Sure.
Hey, we've had it from David's roof. We might as well have it from Andrew's garage.
Yeah, why not?
Yeah, let's do it.
What we really want is a tour of Chris's workshops, and
Yeah.
I was tempted
I
today.
agree.
yeah,
Just didn't.
and that's my transition. Just a reminder before we break in with Chris. Post your questions in the chat, in the live chat. Don't hesitate. We appreciate it. So with that, we were talking a little about radioactive material for real. Chris, maybe you can talk a little bit about, what you're able to measure, and what you were trying to measure with your Steampunk Geiger counter.
I guess, shall I show the folks at home what we're looking at first? Let's have a look.
Yes.
I'm going to change camera. Here we go. Yes.
There she blows.
So this is my project that you may have seen on the internet, alive in the flesh. So this is measuring a count of background radiation right now. And I have the Nixie Tubes giving a current readout of counts per minute, CPM. And this is the actual Geiger tube itself here. This is what detects the radiation. And then these are sort of trying to replicate an old school display called a Decatron, which you can see it increments. I don't know if you can hear it clicking, but you should see this increments on every click. And then every time this one goes around, this one increments. And then every time that one goes around, this counter will click up as well. So the idea is to monitor background radiation levels and do it in some kind of way that looks pretty, sitting on a shelf somewhere. And it's made out of hardwood because I'm deep into the hardwood scene, as Phil pointed out there.
Your build really started with a lot of historical context. Can you talk a little bit about the genesis of the idea and how you pulled together some of those really, I don't want to call them antique ideas, but the original ways of monitoring radiation and some of those things, how they inspired you that tipped this whole thing off?
Yeah, sure. Well, I guess the initial idea was based around the cheap sort of Geiger counter board that you can get on AliExpress or Amazon, which I'll show you when we take the cover off in a moment. But the board itself, it doesn't do much. It's just like a PCB with this tube mounted on it, and it just clicks. There's no way to get the data or anything. So I thought, wouldn't it be cool to at least have a type of balena sense thing where we can at least get a chart and a graph to monitor levels over time. And then it sort of spiraled into, well, now I need a case to put it in with the Raspberry Pi. And then I kind of like Nixie Tubes, so I added on the Nixie Tube aspect to get a counts per minute, and it sort of like escalated from there and then I discovered these things called decatrons, which they give a nice visual indicator of a fast count, so you can see when it's counting slowly, you just get a small, like it just moves every now and again, but when it's going fast, as I'll show you in a minute, you see it spin and it sort of draws the eye to it. It's like a warning. So it's kind of one of those things where I just had a picture in my mind of what I wanted it to look like, and I just had to keep building it until it came out and became a real thing. It wasn't any sort of specific idea. It was just like a meandering assembly.
Well, and that it brings up the two main aspects of this project, which are, excuse me, the artistic and the technical. And for the benefit of our audience, why don't you explain some of the, in kicking off some of the craftsmanship that you incorporated. I mean, yes, you could put this in a plastic box and be on your way, but it evolved into something much more of that, right?
Yeah. And yeah, 2020 does seem like a good year for this project. It's now I've got this ready just in case anything else should happen. But yeah, it's like, I guess, like over the past few years, I've been playing around learning machining. And so like, I like to build things on the lathe and the milling machine, and that kind of inspired these displays, which these are like built on a lathe or machined on a lathe. And then it's sort of, my dad's always been into woodwork, and I was sort of more interested in metalwork and machining, but so he has a wood shop, which means I can machine up planks of wood like this. This actually was like a scrap piece that I just found in the garden. But once you sort of plane it down and cut it all up and process it, you can get a nice finish out of it.
Mahogany, right? Rich
mahogany. Yeah.
Hey, do you know how in tune you are with our community? We ran an informal poll. And it was, so if you finish all the internal components of your amazing IoT project, which case would you choose? And we had 3 options. Make it out of plastic, make one out of wood, or go caseless, baby. And the majority of the votes were for wood. So
there we go. See?
Yeah, right on.
It's not just me into the hardwood.
Mm-mm.
Well, there's something about, if you're going to have this thing around, it's a lot nicer than have it sprawled in a bunch of pieces, which is the quick and dirty way. I mean, this is, it can be displayed. It can be displayed in boardrooms, as they say.
Yeah, it's I wanted something that would sit on the shelf and just look pretty in the background. I didn't want it to look like a typical like Raspberry Pi project with LCDs and TFTs and like all the modern stuff. I just wanted it to sit in the background. So that's why I built, so you can turn off the clicking noise, just so you can have it there looking pretty. You don't have to actually hear the clicking the whole time.
And let's remind everyone that it's not that you skipped, building something with your 3D printer and having like LEDs and whatnot scattered around, because during the holiday season, you have that blinding 8-foot tall tree setup. So you've earned this spot, Chris. You've already done, level 1, and you're like, I'm off to bigger things. So
I mean, we can bust the LEDs out again. They're not forgotten. They'll be back.
We need a couple more months. It's July still.
We could bust out the web UI for the Christmas tree on the happy hour.
Now, in addition to the hardwood there's brass. You have the Nixie Tubes. Explain a little bit about those Nixie Tubes, because when I was reading about this, I was like, wow, I've never heard of these. And sort of explain what those are. It's not, we have small camera screens, but what's going on there?
What's going on with the Nixie Tubes themselves? So it's kind of like I think these are even pre-LED. You used to get the LED segment displays where it's like a figure 8 and you can turn on each segment. This is like the step before that. So it's a vacuum tube, and it uses a high voltage. I think it's a 170 volt DC power supply in there to drive these. And they basically have each, I don't know if I can, I might be able to use this other camera to get in more detail on the Nixie Tube. Let's have a look. This could go well, or it could go wrong.
You got this, man. We believe.
There
we go.
Cool.
See if it's going to focus.
Oh, nice. Nice.
Look at that.
I don't know if it's hard to see, but in each one of the tubes, there's a metal outline of each number. and when the current passes through the number you want to light up, it sort of gets this orange plasma glow around it. So you can see that middle one, the number 1's lit, but you can see the number 3 in front of it, which is not lit.
And that's all hand wired, right?
I don't know how these are made. Like,
No, I mean like you interfacing with it. Like I remember that picture from the post.
Yeah. So I got some cool little boards off of Tindy, which are Nixie Tube controllers, but I wanted to like hide them away back in the depths of the case. So I sort of hand wired them and assembled the tubes to them, which we might be able to get a glimpse at. But I wanted to make this all kind of like modular as well, because I like things where you can take them apart and put them back together without resoldering them. So I made all these socketed so you can pull them out.
Nice.
And then they've got a little RGB LED behind there to backlight them as well. Like, so you can change that orange light to any color.
Now, what?
Thanks, Lance.
What would we have people have seen a Nixie Tube in back in the day? I mean, were they cheap enough to be everywhere, or were they?
I guess it's mainly industrial equipment, because I think back in the day when these were popular, you didn't really have like home electronics. Because I could see you could sort of use them on like a radio or a stereo or something you needed to tune in. But I think it was more sort of industrial stuff. There you go. You can see the layers there. So each one of those layers is one of the digits.
I have an obscure reference that I think this group might get. So for me, like when I saw this project, it reminded me of, and for you PlayStation 1 owners out there, if you played Final Fantasy VII, the original, like one of the first missions is you need to escape this like facility that's going to be bombed, and the timer that is going down in the corner of the screen is in that style. Super,
is it?
Yeah, up in the corner. Super random reference. Feel free to jump in the chat if I've hit a nostalgic note with you.
Because I was going to say, there's in the Chernobyl series that was on TV last year, it's like the power meter you can see like going up is made out of these. Like just before the thing blows up, it's Nixie Tubes.
Excellent. Now, the working end of this thing is that tube above. Can you explain that?
So this is where my knowledge starts to run out. But as I understand it, it's passing a high voltage through the tube, and so when the particles hit the tube, they're able to make a connection ever so slightly, and so it's able to count those pulses that are caused by the particles hitting it. So I have a sample of this is a mantle from a gas lamp, which is one of the few sort of household items you can get that's radioactive. So for your like camping lanterns, these are used, and so I think these are made of thorium. They're quite safe when they're new because they're kind of like in bags and they're all flexible. When you start to burn them, they go all brittle and fragile, so they're a bit more dangerous. But I think that they're so low that they're still able to sell them. So you see, as soon as I do that, then you see the thing starts to light up.
Wow.
And so you see what I mean about how you can see the count is fast because these things spin around. And you see the lever pulls on the mechanical counter.
What's that CPM, Chris? It's a little hard to read. Is that over 100 now?
It's 360. It's going up. Yeah.
Wow.
450.
Wow. Now, I always had heard that certain smoke detectors are.
I don't have any uranium, unfortunately.
Is it true that smoke detectors have a little bit of radioactive material?
Yeah, I think the older ones do. I'm not sure they do so much anymore. Like, I think I'm pretty sure the newer ones work on like a laser scattering principle, but yeah.
Yeah, the smoke detector one, I believe, is pretty well sealed up and difficult to get a reading from. The radioactive part is in a very sealed chamber, so I'm not sure you could get much out of it.
You don't want to go smashing that. Now, that tube, you can buy boards that have something similar built right in, right? Is that
so
that's sort of the original, ultra simplified concept, but this is obviously much cooler.
Yeah, so all it is one of those boards that has the tube mounted on it, but I wanted to take the tube off and bring it up to the top so it looks a bit nicer, because you could leave it inside the case. So if I start to, we can take bits apart, I think. So I already took out a lot of these screws in advance of this because it it takes a lot.
And how many screws do you have?
It's like 18, I think. I don't
For
know.
security or for what?
No, it's for the look.
It's for fun.
Yeah. Now, let's talk a little bit about the technical components. We talked about the Raspberry Pi. What are some of the steps that you had to go through and the electronics that you had to assemble?
If you give me a second to open this up, it might be easier because then I can point at stuff as we go.
And I think it's important to mention that now what you see on the actual Geiger counter here can also be replicated and viewed remotely.
Yes, there is a Grafana dashboard where you can see the count that's displayed on these tubes and a graph over time as well. I see we've got a question about a banana. I know bananas are radioactive, but nothing even close to radioactive as that gas mantle sample.
I hope Hardwood Reddit guy is watching this, or gal person, because look at the respect that you put into your case to use actual rubber feet. Like, you could have cheaped out and used those fuzzy, the little like cloth.
The felt pads.
Yeah, the felt pads, but you did not. So Reddit hardwood enthusiasts out there, if you're watching, respect your man here.
So I need to disconnect the mechanical counter here because the servo is mounted to the bottom. So, and
what our viewers might not be able to see is there is basically a push rod that's coming up through the
so it's just
the top.
Here. This push rod right here. It's connected to a servo in the bottom of the case so that it's able to increment this counter by pulling this lever. So now you see if I lift the case, the wire comes down.
That sound is so soothing too. When we were working on the video for this, when you hear the rod move, like it's just like very ASMR.
This is where I need to unhook this. Pliers. This is why I've got my toolkit.
Well, and it's interesting too, like you say, that it's designed obviously to sit and be sealed, and it can work, and you can program and reprogram the Raspberry Pi without having to open it. But you can also do maintenance and do things like that because you can take the various pieces apart at will.
Yeah, so this is what I was talking about, how I like to make things modular so you can take them apart and reassemble them without too much trouble. But here, so there's the Raspberry Pi. This is a 3A. I don't know if you can see that.
Yep.
So that's the Raspberry Pi. This is the Geiger counter board. This is the one you can buy from a kit. I think you can buy it as a kit, like with no components mounted on the board already at all, so you have to solder it up, or you can buy it as an assembled board, ready to go. And it just works on 5 volts, and it puts a pulse output, which we can then count with the Raspberry Pi. These are the counters that drive the LED displays. So I'm taking the pulse that comes out of the Geiger counter, feeding it both into the Pi to count it for Grafana, and feeding it into the counters that sit on this board here. And they are the CMOS logic. So they're decade counters. So you basically feed them a set of pulses, and they're incrementing those LEDs 1 through 10. And then when it carries over, it goes on to the next one, and then you get up to 100 count. And so this sort of stack of boards is a home assembled PCB on Veroboard, strip board. And then under there, you've got the Nixie Tube drivers, which are those 3 boards you can see right there. So in theory, this is the interface to the Pi, which has SPI in it and the 3.3 volts and 5. So I can unplug that like that. And then these are the ribbon cables for the LEDs on the top, so I can unplug those.
And just for the benefit of our audience, so you're collecting data from the tube and using it both digitally and for mechanical.
That's right.
Analog.
And I can pull this out in theory. This is the first time I've taken it to bits since I finished putting it together.
Oh.
Well, it's a good test. So there you go. You can see that's
nice.
the.
How's electricity working, Chris?
Sorry?
How's the electricity flowing into the full circuit?
So I've got a DC jack here where I put in a 5 volt power supply, and it's just like a laptop style brick power supply. and then I pass that down through here. So you've got the power switch on the front, and then after that, it's going into these. You can see the 2 terminals here, screw terminals. And so I've basically, from those screw terminals, I'm taking some off to the Raspberry Pi, some off to the Geiger counter. The Geiger counter is that connector there. The green one is the pulse wire, so that's going over to the Pi. That's the big connector I disconnected first, is like the SPI for the Nixie Tube drivers. These are the 2 CMOS logic chips that I was talking about. And then this is the 170 volt power supply for the Nixie Tubes. And you can see I've got all the headers here where the drivers plug in, or rather this board plugs into the back of the drivers and faces with these pins here.
So how many amps do you need at 5 volts to run all that, Chris?
I think, and now it's a good question, because initially I thought, oh, it's going to need a high amperage to drive these Nixie Tubes. And I was just running on a Raspberry Pi power supply, like a 2.4 amp, and it was fine. But then there's like an overdrive feature in these drivers, which I haven't been able to get to work yet, that can make the displays brighter. And so I've got a 6 amp 5 volt power supply driving it, although I don't think it's using anywhere near that much. But I got it just in case that when I get the overdrive feature working, I can get a bit more brightness out of them.
So could you add a pot to affect the brightness that way?
I guess you could, but it would be a roundabout way, as these are, each one of those has its own microcontroller. So I'm controlling it with SPI to say a brightness level. So
Right.
you would have to feed the pot through the Raspberry Pi through an ADC. But yeah, the controllers are pretty cool. So it's got an RGB LED on it, and you can specify the color you want, and it can do fading transitions between digits on the Nixies as well.
That's really cool. Now, none of these components are that expensive, are they? How much was the actual board, the specific Geiger counter board?
I think it was about £35. I know Alan bought one recently. How much did you pay for yours, Alan?
That was around $50 US. Yeah.
And I think if you want to wait longer, you can get them from AliExpress, can't you?
Yeah, I think they're definitely less expensive if you go that route. I bought mine on Amazon, and it was fully assembled.
I imagine some of the components of the box are pricier than the electronics themselves.
No way, man. Garden mahogany.
Yeah. Well, that's the thing.
Garden mahogany.
It's like I always build things out of scrap. It's like the whole thing is defined based on what scrap I had lying around. So the metal is all offcuts, and the wood was from the garden. This is like used to be a garden bench that I've just planed.
I was like, where do you live where like you just have mahogany?
Mahogany benches sitting around.
It's some old garden furniture that was like rotting away. But then once you plane it and like get the core of the wood out, it's fine.
Yeah.
This was from an old radio-controlled car that I had probably 10 years ago. I think the only bits I purchased really were the Nixie drivers, the Nixie's toggle switches, and the 2 boards. Like the actual case components are all just made out of offcuts.
Nice work. Was I the only one that thought like I want a Nixie Tube PC like performance counter now? I want to see like all my PC specs but in Nixie Tube format. Full RGB LED.
That would be nice. Like you want a frequency count in Nixie Tubes on the front. So you can see when it like auto throttles. Yeah. That'd be cool.
So the key, the total cost that you have into this is hard to measure because you did, gather up pieces. But for someone who's not building, the steampunk part, the electronics in this device are under $100, under 100 pounds.
I would say so. So it's a Raspberry Pi and the board for $50, as Alan said, and like the old CMOS logic is all cheap. I think the Nixie Tube drivers were £18 each, and then the Nixie Tubes themselves were maybe £6. It's nothing's like super absurdly expensive. We're quite lucky to be able to get all these parts for cheap.
And everything's pretty readily available. I mean, COVID-19 notwithstanding. You can source these things. Now, there was a question about not only that, but the time. Now, you spent quite a bit of time on the calendar year building this. Can you talk a little bit about the time you invested?
See, that's a difficult thing, especially if you're an amateur machinist like me. It's like I don't necessarily know the quickest way to make something, so I probably go a roundabout way. But it's like the copper parts are just standard plumbing parts, but this brass, that brass, like all the brass parts are all custom made on a lathe from like a piece of raw bar. And that's why I brought this piece that I was throwing around. This is one of these, but I actually stuffed it up, which is why it's here and not there. So the first one I made out of stainless steel, but stainless steel is notoriously hard to work with, depending on the grade. I don't know the grade of this because it's just an offcut that I had that I got from an auction at one point. But it has the property that if it gets hot while you're working with it, it hardens, and then you can't cut it anymore. So
wow,
each one of these it's been machined on a lathe from a solid bar. So if you imagine you had to cut this pocket out and drill the hole and drill these holes, and then each one of those has to be tapped. And you can see if I switch to this camera that it's actually got a tap snapped off in the hole, which is why this piece got written off. You can see it there. I don't know if
and just for our sake, how long, even with your modest skills, just to make that part?
This was probably I don't know, that would probably take like 3 hours. No, I don't know. It's I can remember thinking you probably get one done in the morning. It's like for these the time takes is the holes, because they're M2 machine screws, and each one takes ages, and you're afraid of snapping the part off, as happened like right here.
Now, as it always happens, you're learning as you're going, and you switch to a different material for the other one of these.
Yeah. So that one's the other one's aluminium. Let me change back to the other camera.
And that must have been much faster to mill.
Yeah, aluminium's like butter. After you've made these two out of stainless steel, aluminium is like cheese. It's like you can just power through it and make it in like an hour. It's like a different world. And then the same thing happens when you go from like aluminium to wood. Wood is like if you've got wood on a milling machine, it's like there's barely any material there.
Was there a reason that you wanted the stainless steel, other than the look of the stainless steel? Or that you just had a piece of stainless steel. You just had a piece of stainless steel around.
Aesthetics, baby.
Yeah, it's the look, and because the stainless, you can see it sort of has like a deeper, dark, like sort of like a shadowy shine on it, whereas the aluminium is brighter, and the stainless steel will just keep looking like that for a long, long time, whereas the aluminium will gradually corrode and get like an oxidation layer on it.
Right. It's fascinating. The various parts, and I'm sure you discovered other things along the way, materials wise. Were you ever worried about heat or ventilation on this thing? It doesn't really create that much. Were there things that you had to revise that, based on midstream, weren't going to work, other than milling problem?
With a project like this, it's just sort of it's evolving, so you like design the rest of it to fit the parts that you've already done. So it's kind of like I set the length of the box was decided based on the width of the Geiger counter next to the Raspberry Pi. So if I change that, it's like you can see like these two boards here happen to fit side by side. That's because I used that measurement to decide the length of the box. And then so if that's set, then you have to then figure out, okay, well, I've got to fit 2 switches and 3 Nixie tubes. So how's that going to work? And then some of it's like kind of guesswork, because it gets to the point where I know what that is and I know what that is, but I don't know what all these bits in the middle are going to be yet. So I'm just going to make a rough approximation of what looks right and then solve the problem afterwards. So it's like I know I've got to squeeze that into this space, so I'll design it to fit that space.
Right. It's fascinating. And we were kidding you when you first started to unveil this, that the skills that you use to build this project are basically the skills that would enable you to build a house, which you've also done. So, there's plumbing, carpentry, electrical, and hardware.
House building is not my favorite.
I gotta know. Marios asked this a bit ago, but do you have
that's a good question, Marios.
Watch with glowing parts? They might be radioactive.
Yeah, I know the really old watches with glowing parts are radioactive. I remember I had a physics lesson at school once, and the professor like produced this old watch, and it was radioactive. But I don't, unfortunately.
Oh man.
I did try one. I tried one of my grandmother's old watches, and it did have a glowing dial, but it didn't register anything, at least on mine. I don't know if maybe it wasn't old enough, or there wasn't enough of a large dial, but I wasn't able to reproduce that. But it's probably the watch.
I think the level of radioactivity is so low in comparison to something like that gas mantle, though. It's like bananas are slightly radioactive, but you'd have to like place the bunch next to it and watch the graph like very slightly dip, or go up rather.
It's amazing. Talk to us a little bit about the coding side. When you put together the application itself too, because this works really by itself without the Grafana dashboard. But talk to us about the process of extending the capability to provide that digital feedback.
I guess that's in comparison to the actual physical build and the manufacturing of all the parts. The programming is pretty easy. I mean, it's just using edge detection on one of the Pi GPIOs. So as soon as the pulse comes in from the Geiger counter, it's just maintaining a count, and then it's sort of counting the number of pulses over 60 seconds, and then sending that value to the Nixie Tubes. I mean, yeah, it's like the programming was probably done in like 30 minutes or less. So it was certainly the easy part.
What are some of the components of the actual software? You're running 3 containers, one for the counter itself, and then InfluxDB to take that data, store it, and then Grafana to create a dashboard. Now, with Grafana, it's obviously very easy to create different dashboards. Did you have that in mind during the process of, I want to replicate everything that's on the physical device, or just a couple? What was your thinking?
It's quite simple again. So it's like you can record the counts per minute. I'm like trying to assemble this and talk at the same time. But so you can record the counts per minute, and then there's a conversion factor for each Geiger tube that you use to convert it into sieverts, which is like a more, I think, is that the SI unit for radiation? I'm not sure, but you can convert that based on a multiplication factor for the tube, and so you can record that as well. But it's just, I think, I can't even remember the update interval. It's probably every second it's updating the count on the tubes. And then I think every 10 seconds it's inserting the value into Influx. And so you can get a chart. I mean, I can turn this on in a minute, and maybe we can link the Grafana dashboard in chat.
Well, it's the one thing that the Grafana and InfluxDB offers too is historical data, right?
That's right, yeah.
Obviously, the Geiger counter is giving you real time, and there's no way to capture that. It would be interesting to see over time your ambient radiation using, or if you go for an X-ray.
That's how people pick up the kind of accidents, isn't it? Because it's like if you're thousands of miles away from a power station, you're not going to see it as like the counter going mental. You'll see it as like a slight increase that no one would even notice unless they had a counter.
And you do have a cloud coming over you from Eastern Europe, right? So
apparently, I think, or is that past now? I don't know.
Yeah, I was just tracking something recently that sort of announced it as something all new. I was like, no, it's been happening.
It's been done.
Yeah, it's blown through. But yeah, and when we bring it up here to see some of the historical data, which is interesting because it's like the Balena Sense project where half the fun is seeing it in real time, what the temperature is and humidity and air quality, but a lot of the value comes from being able to look at it and go, oh wow, it got really hot in here, or whatever else. And and then there are things that you can do with that data, right? You can trigger other events.
That's true. Yeah,
turn on fans.
You could set up an alert. You could turn on a fan when the radiation level gets too high. I mean,
drop a lead cage around you.
Yeah. So Matthew has a good question. It's just a Python script that I hacked together. It's nothing fancy at all. The repo link is around somewhere. I'm sure someone will put it in chat. Let's see if this still works after I've taken it to bits and put it back together again. So you can see like this starts working straight away because that's all done off old school logic, but these take a little while to come up because they're driven off the Raspberry Pi. So you need to wait for it to boot.
And how the audio works as well. So do you have
audio?
A
oh yeah, so the little the Geiger counter comes with a little buzzer on board. Okay. But I've actually desoldered it and passed it through this switch, and then that's what that little hole is that you can see just there. The buzzer is underneath that hole.
Hey, Chris, do you feel like you got any performance hit from extending the tube like that? Did you notice any change once you moved the tube off the board, made it external?
No, it seems to be about the same. And then I compared it side by side with that other Geiger counter I bought. The second one I bought to check the first one was working, so and they seem to get about the same reading.
Yeah, that was the question we had, the accuracy, because when we were talking about this previously, how accurate is it? And the answer is it's very accurate. It's not just
it seems to match the more professional one I've got, which I'll get out in a minute and see if we can do a matching reading if we've got time.
Oh yeah, you should let everyone know why you got that.
Yeah, so it's like this thing started going absolutely mental. I see one of the Nixie Tubes is out now. I might need to just touch the connection. But this thing started going crazy and saying abnormally high readings. So I was like, well, is it a really high reading or is it broken? So I got another Geiger counter.
Calls and like hear the clicking, right? Like on our meetings, and we're like, "You okay, man? Is everything okay over there?"
Yeah. I would say that's. Oh, actually, I'll leave that for a minute. I'm not gonna just take it all apart again. Yeah, I think the where I've clipped it back together on hasn't quite caught, so it's not getting the SPI signal to turn on the real display.
It wouldn't be IoT happy hour if a live code and live build session didn't break something, right? So this is on brand.
I mean, it was the first time I've taken it to bits, so
yeah, it's continuous improvement, Andrew.
Yeah.
He's iterating.
But the trouble is now we can't see what the value is. Let me find the dashboard and I'll link it in chat. Let's get the Grafana link. I can hear Alan's clicking in the background. That's not mine. If you can hear a Geiger counter clicking, it's not me.
And
I'm adding the sound effects remotely.
Yeah, it's my sound is turned off.
And do you have yours handy to show?
Yeah, sure.
Which is a more base model, but has all the same moving parts.
Well, I'm not sure base model is a good description. It's like just as fancy, but in a different. Alan's taken his in like the more modern direction.
Well, as Chris's is a work of art, mine is more like a piece of laboratory equipment. But his inspired me to build something that was, that had the kind of, that has like a fake LED display, because I love the idea of being able to see, as the reading increase, something visual. Because if you just have these readings, you don't always notice that. And I also wanted soft switches on here so that I could reprogram what this does. So this one, if you can see the icon, this turns off the speaker. So now the speaker is set to off, and it is using a relay board because it is a soft switch. So I basically have all the same parts inside, but obviously a very different effect than what Chris has. I spent a lot of time taking apart Chris's code and adding what I need to drive this display. And then this can also change, I need to debounce my switches, as you can see. But that then gives you a little bit of equipment information there. And then when you go back, it goes back to this display. but it uses basically the same repo as Chris's. So it does have the Grafana and the influx in here. So it does have the dashboard. And then I have a few other icons that I'm working on for down here. But same inside, but obviously not a work of art.
So we can see the board on yours, Alan, can't we? We can see how the tube is still on the board. Yeah, and you've relocated the buzzer as well, haven't you? So you can turn the sound on and off.
Yeah, so the buzzer, oops, I'm in reverse, so I'm moving the wrong way. But that's the where the buzzer was mounted. And then what I did was ran it through a relay instead of a switch so that it can be controlled through software. And then I have it mounted on this temporary breadboard right here. So when I'm done with this whole thing, I will move it to an actual circuit board.
Nice. Yeah. Not enough mahogany.
Yes.
Beautiful. And we should note that you don't have to break the board to take the tube off. It's just it's in a couple clips, right? Mm-hmm. So moving it and remounting it isn't a devastating change. That's amazing, Alan. Nice job. And I like the screen, to provide some of the onboard information, which is pretty handy. Let's see. So, Chris, you're talking a little bit about the code in the Grafana side. So this sort of dual capability provides a lot of extra functionality, really. Yeah.
I mean, I guess it's nice to have the historical charts because that's what's useful. Because if there was some kind of incident, you need like a baseline to see like what it was in the past in order to see what it is now. It's like, say if you like the first time you turned it on and the radiation level in the background was higher than what it should be, you would never know because you haven't got a baseline reading. And those all vary throughout the world and throughout the country. Which is why Phil's suggestion of feeding a fleet database and having a map with all the readings on is a good one.
Right, and just conceptually, that would take data from many instances and feed them into like a collector. Which should. Because
I know, like down here in Cornwall in the UK, I think it's quite high in terms of background radiation comparatively because we have a lot of granite in the ground, and like when you build a house here, there's radon gas that comes out of the ground, so you have to put in vents under the house to get the radon out of the way. And yes, it is a Pi 3A plus. That's right.
Is it sensitive enough to pick up radon levels?
It should be. Because of all the precautions that people take around here, you don't really get any buildup. I think it's only a problem when like the foundations of the house are closed in and you can get a gas buildup, but everyone's aware of that, so it's all vented.
If you inverted a bucket on the ground and put your Geiger counter inside.
I mean, it's probably not that I mean, the things have to be pretty bad for that to be the case, I think.
I saw Geek Till It Hurts that he's missed most of it. These IoT happy hours are recorded and are freely available on YouTube after the fact.
Catch it on a rerun.
You can catch it.
What's a rerun?
Yeah. Yeah, that's an interesting concept.
Rewind the tape? What? Sorry.
Yeah, what's tape? Someone, and I'll admit it's David. He said, if you want to test this, someone asked earlier where you got your little piece of radioactive material. Now you took that from a lamp.
Yeah, a gas lamp, one of these. Yeah. That's right. Yeah, like one of the classic style gas lamps for camping. But as I said, it's a brand new one. Yeah,
you actually took it off of yours?
No, it's a spare one that was in the bottom of the box because they go, as I was saying, they go quite brittle when they're on there, and so you wouldn't be able to take an old one off without it like crumbling into pieces.
And so you shouldn't go hunting for radioactive material on the interwebs.
I guess you can probably buy those gas mantles, like if you needed to test your Geiger counter.
And we don't recommend taking apart an old fire, smoke detector, things like that.
There's that website, isn't there? United Nuclear.
Yeah, I remember onboarding in Balena my first couple days, and I sat next to Chris, and he had that website open. And I'm like, what is this guy doing? This was like 9 months ago or something. But he had that site, and I'm like, he's like, oh, I'm just shopping for radioactive material. I'm like, all right.
Yeah, because obviously, like, testing your counter is a valid use case. You need some.
Totally.
Like, how do you know if it works?
Do we have affiliate links to that site? Do we need to put them in the video?
We
have discounts.
There's an interesting
Do you have a
man.
code? Is it
like-
Chris 2020? And you get like 15% off your thorium purchase.
Yeah, I'll put the link in the chat. If you go to that page, there's an interesting GIF of a guy in the bottom left-hand corner who's like, it says looking for some uranium, and he's like going with his eyebrows.
Full
like,
disclaimer: we're not sponsored by United Nuclear. Okay. Like, jokes aside,
I mean, I've never actually bought anything from there because I have my gas mantle, but maybe
Yeah.
Alan needs a
you're
test
on your.
piece.
If you buy anything, you're on your own. Okay, everyone.
Yeah, those mantles are actually, you can just buy that radioactive piece on eBay. There's a lot of people selling just the piece that you had in the plastic bag.
Yeah, because that's
You
the
can just
spare.
get that. Yeah. So those are available, and they're pretty legit, I think.
What makes them radioactive?
It's the thorium they're made out of. Like, I'm not.
To make
I
them
don't know,
flame retardant or something?
I think it's the way. I don't know how it works, but it's like the material has a property where when it receives the energy from the gas flame, it outputs like a greater quantity of light than it would be.
Just
normally.
like a steamed ham.
Yeah, just like when you burn your ham in the oven.
Yeah. You hear that, David? Next episode list. How thorium works. Gotta add that on there. He's shaking his head.
We have just a couple minutes left. Are there other aspects of this build that you want to share, Chris? That, I mean, it's a completely impressive and painstaking and labor of love. Clearly, you must have got a great sense of satisfaction when it was.
Yeah, it's
complete.
nice to see the thing done. Yeah, it's one of those things where you just work on it forever and ever and ever until there's no more things to do, and then you're like, oh, it's done.
Do you think there's enhancements that if you were to do it again, there are things that you would add on or things that you would change, other than some of the things we already talked about?
That's a good question. I think I would probably, instead of using the strip board to get a prototype PCB going, I would design a PCB and get it manufactured. So it's a more solid thing. Because as you saw, the middle Nixie tube went out because I dismantled it and put it back together. Like, it would be nice to do a proper PCB prototype. But other than that, I think I'm quite happy with it. I mean, there's some annoying parts, like you can't line up the screw heads on these little things because the screws are so tiny. There's not enough movement. I lined these ones up, but these ones again were quite difficult. It's just one of those annoying little things. And all those are lined up along there, so it's...
Okay, Chris.
Yes.
Do you know what my favorite part of this project is?
I do not, Andrew. Why don't you tell us what your favorite part of the project is?
It's that it has inspired Alan to build one and get really competitive about it. And
Yeah, I like that too.
I extend that invitation to our community as well. If you all see this project, any of the other ones that we've shown on the show here or are in the labs repo, and you're like, you know what, I can do that better. Like, I dare you to. Go ahead.
Yeah, we'd love to see that.
Yeah, and then you can come on the show and you can show it off. You can show off your rich mahogany case design if you'd like. We're more than happy to host that.
Now, obviously, for those who have 3D printers, you could do some very interesting things.
Yeah.
And don't hesitate to show those off. Yes, we're talking about you, Matthew. We know that you're just a wee bit competitive too. With that, any other comments from our, I hesitate to call them peanut gallery, but our folks, is it just a tremendous build? Check out the blog post that Chris put together, and you'll actually find references now to this build in a number of other non-balena media. That you'll see also a video that Chris and Andrew and others put together that show some more of the Geiger counter in action. You'll also, from the blog post, see some of Chris's original sketches. So when a time capsule is made and they'll wonder what drove him insane, they'll be able to look back and see his sketches.
You make the sketches sound like so much more than what they are. It's like, oh, the original sketches.
Oh, but you know what? They totally struck me as like, oh, this is how the iPhone started, or this is how Ford brought up his assembly line, idea.
I like how Alexandra doctored it too. She really wanted to bring out the like mad scientist in you. Alexandra's our designer. She's like, no, I want to do it this way, and she nailed it, because if you look at that image, it's very
I gave her some like terrible photographs of some oily bits
they're
of
like
scrap paper.
stained, man. That was gross.
Yeah.
And of course, all the
don't
code
stay
is
clean in a machine shop.
yeah, and all the code is available. You'll find links in that blog post as well, so you can deploy these containers and do the Grafana bits.
I really recommend checking out the Nixie Tube drivers. They make it super easy to get Nixies on your Raspberry Pi.
Hey, Alan, when you did your version, you used the other guide too, right? Like we when we were launching this stuff, we wanted to make sure there was a lane for everyone, right? People who have access to multiple shops and mahogany in their garden, or folks who just wanted to buy some parts off AliExpress or Amazon. Did you use the simpler guide, Alan? So that's
I did. I used Chris's simpler guide. I actually forked it. And I'll post mine when I'm done. If anybody's interested in using a TFT display, I'll also post my repository.
That American competitive spirit. See that?
We'll get that. Chris and I will try to work together. Maybe we can get them into the same. I think that would be even better to get the TFT driver in there.
You all are witnessing Ford versus Ferrari, but
not at all. There's no competition here. Mine is nothing like that work of art. Mine is
it's Ford versus Ferrari, but we're both going to build the same thing. And like collaborate.
Well, and it's indicative too that Alan built his in 2 weeks. Which gets to that original point someone asked about how long does it take to do. A big part of Chris's was the art that he put into the display. It's really a phenomenal piece of it is art, but it's functional art, and it's amazing. But it shouldn't deter you from creating your own and taking advantage of the containerized infrastructure that makes modifying it and personalizing it very easy and doable. And when you do look at the repo, it is small and easy. This is it's amazing.
Yeah, exactly. The key thing, as you said earlier, John, is like the components that make up the core part of it are cheap and freely available. So it's like it's there for anyone to put their interpretation of on top.
Absolutely. Well, with that, we'll let Chris have the final word. And thanks for joining us. Look for us next week. Same bat place, same bat time. Chris, for your reference, that's a reference to 60s Batman.
Is that Batman reference?
And we look forward to you. Thank you for participating. Thanks to all of you for watching, and we look forward to seeing you again soon.
Thank you. Thank you, David.
Bye.
Bye.